Hi, and welcome to this quick tool review. This time around we'll be looking at the Viking 12-volt jump starter kit from Harbor Freight. And this is the smaller of the two models that I saw at the current Harbor Freight. There is a third model that is the same as this one, but includes a air pump in it to pump up your tires up to 250 PSI, but I didn't need that feature. I got this because I have an immediate need for it. My wife's Honda keeps killing the battery as it sits on standby. You know, as it just sits parked in our driveway. Because of the pandemic, we don't drive it very much. And if you leave it more than 3 or 4 days, literally 3 or 4 days without driving it, the battery's dead. So I got this to see if I could, rather than pull the jumper cables out of the back of my car, run them over, start my car, start her car. It seemed like it'd be easier to have this because it's happening so often. So we're gonna try this out. This model is the 1700 Peak Amp model, or 500 amp. Where do they say the 500 amp? 500 cranking amps. There's another model above this, I think is 3400 peak amps and 1000 cranking amps. They claim they're extra heavy duty 2-gauge cables, master on off switch, digital display for voltage. I don't know about current, we'll find out about that. It's got a USB charger, has built-in light, which is nice in case you're on the side of the road, although I don't think I'm going to leave this sitting in the car. I guess that's one of the uses for it, but you know, I don't know if the battery would like that, especially considering how hot cars get in Southern California. 150 at least inside in the summer if you leave them outside. And there's also a 12-volt outlet for car accessories. So that's some nice features. Let's take a closer look. Well, this is the first thing I saw when I opened it up. They should have had that on the outside, but you got to charge this guy completely before you use it. So guess what? I won't be using it on the car this time. I'll have to get my jumper cables this time. Here's the unit out of the box. It comes in a bag, which is nice to keep dust off it, but the plastic in the environment is not a great thing. It comes with a charging cord, an AC cord, which I plugged in because I want this thing charged. Look, you must completely charge it for the first use and after every jump start and every 30 days or voids warranty. So you got to put this on the charger every 30 days. You got to remember to do it once a month. That's going to be interesting. They warn you over and over and over. Look at that. Here again is a warning over the meter, which left some sticky goop on the meter. That's always lovely. There we go. So it looks like it's 80%. Yep, pretty standard. We'll check it out. We're going to let this guy charge a bit, and then we'll open it up and take a look inside. One little interesting detail, they didn't want the clamps biting into the plastic when you first got it, so they put cardboard around the plastic. But the moment you put it away for the first time, you're going to take that cardboard off, and then it's going to damage the plastic. That's a unnecessary piece of paper waste, but they felt for aesthetics, people don't want to have scratched up plastic. They'll feel like it's used, I guess. I don't know, that's crazy. It is really heavy duty alligator clips. This thing started at 80% and it's already at 95% after just a couple minutes, so maybe we will get to use this right off the bat. So on my wife's Honda, it's so dead as usual that you can't even use the electric door locks to open the door. They won't open. So you have to take the special key out and open the driver's side door. So we've opened the car up. We're going to head over because it only took 10 minutes for this thing to come up to full for first use. So we are going to use it. So if you're wondering how dead the battery is, and this is a brand new battery, I bought it like 6 months ago, maybe less, down to 4.5 volts. Normally that would mean shorted cells, and I sure hope it didn't drain it so low that it's killed the battery. So we are going to throw this booster thing to start the car on here, and I'm going to measure the current on starting current and see what we get. All right, so we turned this on, and 51 amps are flowing through this cable at the moment because it's trying to charge the battery. We're going to hop in here and try and start the car. It is so dead, it will not even start. Holy cow, I may have aced my battery. So that crazy poor cell in there is putting 40 amps into this battery right now. That's a bit much. All right, so it's a couple days later. Why a couple days later? Well, I hate to, and I'm really embarrassed to talk about it. I was focusing so much on camera shots, what to say, what to explain about what I'm doing, that when I put the clips here, the alligator clips on the battery, well, I put them on backwards, and I wish I had a good excuse. It's not like this isn't a bright red with a plus, and there's black on this one here. But one of the things that's a little confusing with Hondas is that they have a sensor on the negative lead. So there's 2 leads coming off the negative and 2 off the positive. And on older cars, there were maybe multiple leads on the positive, but only 1 on the negative that usually went straight to the chassis like this one here. And there wasn't anything else. This one does have something else. It has a sensor with a couple leads. And so that's not an excuse. Also, my other car's positive is next to the firewall inside the car. This one is the only car I have that's positive here. Again, not a good excuse. It's not like you can't see the red, but I was in such a hurry to get those hooked up and then explain this and figure out what I was going to say that I put them backwards. Well, let's talk about what happened when I plugged it in backwards. Well, this thing worked like a champ. That's a 125 amp hour battery. This is a 22 amp hour battery. When you turn this sucker on backwards, that one, even though it was down to 7 volts before I started, is going to resist this guy really mightily. And I got to tell you, 50 amps flowed the whole time I was measuring it. So this thing still works. I would have figured this thing would have blown up because that is worse than a dead short. That's trying to run this guy backwards. Now this was a higher voltage, but the internal equivalent series resistance of this guy is much lower than this guy, because that's a much more powerful battery, much higher output current than this battery. So what happened when I did this? Let's get down to brass tacks. Well, for starters, the car wouldn't start. When I went inside, the start button here, right here, was off. And when you pushed it, it would wait quite a while, and then it would just glow white and fade out, white and fade out. So this is a 2017 Honda CRV, and so if you have a similar car, this might be helpful for you. So next thing I do is I go, oh, shoot, well, let's check out the fuse box. Well, you'll notice this jumper here. That's because this long thing here is a group of fuses all in one module. There's also another one here, another one here, another one here, along with a bunch of individual fuses. Well, I checked all the fuses, and the 125 amp fuse in this main one blew, which Honda did as a safety mechanism. So they must have a diode on the other side of this fuse that goes to ground, so that if you make the mistake of putting the polarity backwards on the battery and it tries to backfeed the system, rather than blowing up every electronic module in your system, it goes through the diode short to ground and immediately blows the 125 amp quick fuse. It's a fast blow. Also blew the radio fuse 15 amps. So I checked every fuse in here, which is quite a few fuses, including these multi-fuses. Now, these multi-fuses, here's the part number for my Honda one. None of the dealerships in my area had it. None of the auto parts store in my area had it. And they had to order it, and it took a week to get, which is, to me, ridiculous, because putting terminals, although it's really stupid, putting jumper cables on backwards probably is not all that uncommon. So here's a close-up of this unit here. The 125 amp fuse is right there in the front, and that goes between these 2 terminals here that get screwed down. So I just put a jumper wire in. And then all these smaller fuses are on the positive bus bar and then out. And there's a clip on one side that you got to push off to pull this out, and 2 screws, and then you can get this guy out. So I'm going to replace this guy after I'm done talking about this. So I jumpered this, which now meant I had power in the system again, and the car started just fine. So what else happened? Well, let me show you. So next I came inside here, and every warning light was on. So I went to start the car, and when I pushed on the button, the car started just fine. Everything came up. The stereo didn't come up, and the power door locks did not respond to my key. So I had to use the emergency key inside the key fob to get in the car. I came in here, started the car started fine, stereo wouldn't come on. It said security system enabled, push and hold for 10 seconds to re-enable, pushed and held. Stereo system came up just fine. Just to double check, I turned everything off, and down here is another set of fuses, a whole bunch. There's like 60 over here, another 3. I got all of those and checked all of those fuses with a meter, and they were all fine. Let's see, can you see this? There they are. 60 fuses, 3 over here, checked them all with a meter, they were all fine. So, started the car, every warning light is going on. Says traction controls offline, supplemental restraint system offline, tire pressure monitor system offline. These 4 buttons that control traction control, out of lane or crash avoidance, lane going out of your lane accidentally, and the rear trunk release. None of these buttons would do anything. They were all hard on, and you push them and nothing happened. So I looked at all these lights on and figured, oh my goodness, I'm kind of hosed. I didn't want to drive the car because of all the warnings, so I turned off the engine, went and got an OBD scanner, and it came back with no errors. So I went to Harbor Freight, bought their high-end OBD scanner that's two-way and looks at the CAN bus and looks at all the modules. It said no errors, but that none of the tests have been run. So all the modules have been reset, and the computer thought that they were not tested, so it was saying they were in error because they weren't showing good, they were untested. So before I did anything to reset those errors, I just drove the car down the street for about a quarter mile, and every one of the errors went away. And these buttons started working, and the power door locks with the remote also started working. So if you have a Honda CRV, a 2017 Honda CRV, look at this fuse, and you can see they're bad. If you pull it out, there's 2 screws. You pull it out, and you can just see that the junction is vaporized. I'll pull this one out, and you'll be able to see that in just a sec. And you'll be good to go. To get this guy out, you pull the tab back here and just lift up hard. Now you can see that that fuse is vaporized. The 120 amp fuse is vaporized there. And you can only get this part from Honda, or some of the auto parts stores said they can order it, but it's for me, it was 2 months out, which is crazy. Thank you, COVID. So new one, just put it straight in, and I got to screw that in, and we'll be right back. Original parts back in. By the way, Honda has a fuse puller and spare fuses. You'll need this fuse puller for any of those under dash ones. They don't make it accessible at all. So remember that it's here in the engine compartment. And I'm going to seal this guy up again. And we're going to start the car. Oh, here's one more thing. So, you know, there's these micro fuses. Well, on top of the micro fuses, there's low profile micro fuses, which is what this car uses everywhere. Guess what? Those aren't as easy to find. However, the pin spacing is identical to these micro fuses, and so you can put them in the same place, but they'll just stick out farther. The low profile ones will fit flush, and these will stick out like a 1/4 of an inch or so, but they still work. So in a pinch, that'll work for you. All right, so we're back inside, and now I might get an error because I did pull power to the system. Oh, look at that. We have a bunch of warnings. Tire monitor pressure monitor system error. These are similar errors to the ones I got there. Brake system problem. Brake hold system problem. Notice the error, the lights over there, the vehicle stability assist problem. Notice over there the lane problem, hill start problem. The traction control is both on and off simultaneously. Road departure mitigation system problem. Drive carefully, systems initializing. Okay, so we're going to take this guy for a drive, and you will see what we are talking about. All right, so I'm not going to be able to pay attention to what I'm doing here because I got to focus on driving. So I'm just holding the camera focused in that direction. But when it's safe, I'm going to pull out. I live on a fairly busy street. It's totally a pain to make left turns out of here, which is why we always back into our driveway. So auto door locks just worked. See one of the lights? See the lights all go out? They just went out. And we only drove up the block just a very short distance. Now, in case you're wondering, is that just a temporary fix and are the problems actually still there? I will show you. So I'm going to pull over here, put the car in park, put the emergency brake on, turn off the car. So I'm going to start it up again, put my foot on the brake, start. And the errors are all gone. So what your car needs to do is needs to go through a bunch of self-tests, and once it does that, then they'll be okay. All right, so let's talk about the Harbor Freight Jumpstart thing. This thing performed amazingly. I got to tell you, I am blown away. I would have fully expected this thing to be blown up. Why? Well, because 125 amps went through this protection circuit. You can see right there, 125 for this first. So there's probably a diode on this side to ground in reverse path. So in normal operation, the diode would be off. If you put your leads on backwards, so you put the positive on the negative and the negative on the positive, that diode goes forward and allows current to flow through here. But let's talk about the, I don't know, the really big, amazing thing that I noticed here, which is, one, the battery is where these probes are connected. To the battery, this thing would look like a absolute dead short. It's actually trying to put voltage back into this guy. Now this is a higher voltage, so it means current will flow towards the battery, but the battery is where almost all the current's going. This is a path where less current goes, and still 125 amps, more than 125 amps go because it blew the fuse. Think about that. It's connected straight to a battery in reverse. Almost all the current would go into the battery, but yet enough side current went through this part to blow it up. That is a freaking amazing. I give it a major thumbs up for that. So let's see how it's built. So flipping it over and back here, we're just going to open this guy up. Some bunch of screws and plastic, and since there's a heavy battery inside, they weren't shy about the quantity, which is nice. There's bolts on the front that make it look like they go all the way through this thing. These are just sheet metal screws into plastic. That's hilarious. So that's for appearance purely. Okay, oh, I see. The boot hides a couple more screws here. Okay, so inside here, these massive lugs. So here's the voltmeter right here. And also, this thing probably measures current, because the fact that the positive lead goes through here suggests there is a shunt inside here that they're measuring the voltage drop across right here, so that they can measure the amount of current. I think here is a thermal overload device, I'm guessing. Here's your 22 amp hour sealed lead acid battery. The negative goes straight to this terminal. So you can see that there is no problem generating tons of current out of this guy. The PC board inside is not coated for water resistance. The wiring is okay. Everything seems reasonable. And so I'm guessing the metering device on the front measures current and voltage, which I think it does. And again, I think this is some sort of protection device or reverse protection device. Got to be careful about shorting anything here out, because we know the current capabilities of this, which means messing around in here is potentially risky. So keep that in mind if you want to get in here, that shorting this out is a potential to cause some serious damage. So what people are probably wondering at this point is how well can this thing survive really pumping out a ton of current? And I am prepared to show you. It may damage this unit, because what I'm about to do is definitely not recommended, but we're going to give it a shot anyways. So let me seal this guy up. It's fully charged at this point in time. After I ran it backwards on the battery for five or 10 minutes, this was only down to 60%. Connected to a battery in reverse. I am just shocked. It totally wiped out the car battery too. It took me like 4 hours to charge that back up again with another car with jumper cables. So that'll give you an idea how much it drained that battery. All right, let's seal this up and do a test. All right, so I've got my 1000 amp ammeter on here. And so we're gonna try and measure the current that flows here. What I gotta say is, first of all, this is not recommended behavior. This could very easily damage this unit. They do not promise that it'll work on a dead short. But remember, this thing ran reverse on a battery that was at 7 volts, on a full car battery at 7 volts, in reverse for about 10 minutes, pumping 50 amps continuously out. And how do I know it was 50 amps? Because I was measuring it the entire time. So I'm gonna try and run this through this fairly small This is an 1/8 inch stainless steel TIG filler rod. And we're just gonna see what happens. So we're gonna turn this guy on, and we're at 12.8 volts. I'm gonna need to recharge it after this for sure. Let's see what kind of current we get. Holy sh! It went from 12.7 to 12.6, oh, and it recovered back to 12.7. So I got to charge this again. But you can see this is stainless steel TIG, 1/8 inch stainless steel TIG welding rod. It vaporized it. Not a problem. So I have a hell of a lot of respect for this guy, and I'm afraid just to go toe to toe with this, you know, try and short these whole leads out, because that will be unhealthy for it. I got almost 600 amps just through this TIG welding rod here, and that was no problem for it. Mac did maintained it. So that's pretty amazing. By the way, if you're wondering how much juice I took out of it by shorting it out those 5 or 6 times, went from 100 to 65%. So it took a lot out of it shorting it through that TIG rod, but it's still at 65% charge. So I gotta say, I am really, really impressed with this Harbor Freight Viking charger. This is not Jumpstarter. This is not even their big one. They have a big one that's supposedly 3,400 peak amps, can do 12 or 25 volts if you have a truck. So that's pretty amazing. It's got a bigger battery inside. It costs a little bit more. I didn't need that. This will start at V8, no problem. And you can just tell how much current this puts out. This is a really amazing product. Shorting it out did not damage it. I am totally blown away with that. Feeding a large car battery in reverse for 10 minutes did not damage it. I'm totally blown away with that. It was still putting out 50 amps continuously the whole time, which I think was the car battery's problem, or maybe actually was this side. That's only a 22 amp hour battery. So anyways, very impressive. Big thumbs up to Harbor Freight. That is absolutely amazing.